Okay, guys, so in this case, we are going to have a continuation on our lines, considering the straight lines, but this time working with the parallel lines. So we actually need to understand our parallel lines before we do attempt these typical questions. What you are going to need is the concept on the parallel lines. What is it that you are considering on lines which are parallel? You get this part from your grade 7. Remember, when you are given two straight lines that will never meet, these two straight lines, they will never meet. They will never meet. So the indication, or in our mathematics, we are going to use these arrows to indicate that lines are parallel. So when you see these lines, these arrows, this one and this one, it's an indication that the lines are parallel. The lines are parallel. Okay, so having these lines which are parallel, then a line is drawing to cut these lines like this. A line is drawn to cut these lines. This line has a special name called the transversal line. So it is referred to as the transversal line. And what it does, this transversal line that we are seeing, it creates a lot of angles here, a lot of angles that we are going to talk about. Let's say we have got here, this is an angle A, this is B, this is C, this is D, this is E, this is F, this is G, this is H. As we can see, there are 8 of them created by this transversal line, by just having it. So which angles are we talking about here on these lines that are parallel? All right, we have got angles which form a Z like this. Are we seeing this? They form a Z. If you look on the other hand, this side, like this, these angles of this nature, they are created from these parallel lines, and we call these angles alternate angles. So we're going to call them alternate angles. All right. The ones which create a Z like this. Sometimes we are given these parallel lines this way. So they are not going to necessarily create only a Z, but they can create an N. If you consider if your parallel lines are like this, we need the concept of our alternate angles. We are creating the letter N like this. We are having an N depending with the way that you are going to have at the end. So they cannot just be Z. It can be also an N. So this is the presentation that we are going to have on these alternate angles, Z or N. So there is an angle here, there is an angle here, there is an angle here, there is an angle here. What is it about these two angles, alternate angles? They are equal. So whenever you talk about the alternate angles, they are equal, the ones which form a Z, like I said before. So if you consider here, we are forming a Z, meaning to say the angle C and the angle F, they are equal. So C is equal to F. According to what we have there from our diagram, C is equal to F. Also, look at this. It's a straight Z, even though it looks the other way, but that's a Z concept. So this angle D and this angle E, they are also equal. So D is equal to angle E. All right. So that is the condition that we have of the alternate angles. They create or they form a Z or an N. We also have what we call the corresponding angles. Corresponding angles also formed. Corresponding angles. These angles, they do form F like this. They form the letter F. These are called corresponding. All right, let me take it this way. They form F like this, if these two lines are parallel. So one of the angles will be here, and then other one will be here. The other one angle is like this. One is inside and the other one is outside. So it can be also be this way, guys. Whatever that you are given, this is the same concept. The other one is here, the other one is here. So what is it about these angles which form this letter F? What is it about these two angles? They are also equal. So corresponding angles are equal also. They are equal. So on our diagram, we want to trace these angles which are going to form an F. It's either an F like this, or it's either an F going this way. It's either an F which is bending like, guys, that's an F that we're talking about there. Okay, as long we form the F. Okay, let me just leave it like that. So which angles are we talking about from our diagram? We can consider here, all right, like this. That's an F. So you consider angle D and angle H, all right? One is inside, one is outside. So angle D is equal to angle H. You can also consider this F this way, this one, this other side. So you consider this angle F and the angle B, one is inside, one is outside. So meaning to say angle B is equal to angle F. You can take it this side, that's an F here, which is just looking the other hand. So you can consider angle C and this angle G. So meaning to say our angle C is going to be equivalent to the angle G. You can also consider this F, this side here, the angle E and the angle A, they are also equal. So angle A is equal to angle E. These angles, they are equal. Angle A is equal to angle E according to our diagram where we form the F like that. They are corresponding angles. They are equal. All right. On these parallel lines also, we also form angles which are referred to as the co-interior angles. Co-interior angles. It's a name that you need to also understand. Co-interior angles. So co-interior angles, these are angles that are formed, that they form a C like this. If you check on your diagram here, they form a C like this part and this part. These two angles inside. Co-interior, they are inside the parallel lines concept. They form a C like this. One is inside and another one is also inside like this. They are actually adjacent to each other according to the way they are presented, these two angles. So we are considering this angle and this angle on the same line. So what is the concept of these two angles that we are seeing? They are not equal, no, but they add up to 180 degrees. Since they are two angles, we can simply say they are supplementary. They are supplementary. Remember the definition of our supplementary angles. Two angles which add up to 180. They are just two angles that we are talking about there. So we are talking about two angles that add up to 180 degrees. Meaning to say, if you add this angle and this angle, you must obtain 180 degrees. So like I said, they form a C of that nature. So you're going to have this, or it's going to be looking this way, this angle and the other angle that is inside. If you add them, they must be equal to 180 degrees. So considering this diagram that we have, we can consider here forming the C. If you consider here, we are forming that like this. So we are referring to angle D and angle F. Together, we must obtain 180 degrees. Angle D and angle F added together, D plus F is equal to 180 degrees. They add up to 180. Two angles which add up to 180 are called supplementary. So we are saying they are supplementary. Considering the other hand, we have angle C and E this side. This is angle C and angle E. Together there, they also adding up to 180. They are co-interior. So angle C and angle E is supposed to give us 180 degrees. So that is the relationship that you have of what? The co-interior. They are not equal, no, but they add up to 180. The ones that are equal are the corresponding and the alternate angles. And also we have the last part of angles that are created from these lines, which is also the ones that we talked about previously. Remember when we talked about the vertically opposite angles. All right, so we talked of the vertically opposite angles. You also see that they are created by the transversal line that we are seeing here. Remember, vertically opposite angles, the ones that meet where these two lines crosses, where the two lines meet on that condition. When you have got an X like that, you are going to be referring to the vertically opposite angles. Remember, we said previously that these are equal. Vertically opposite angles are equal. These two angles are equal. These two angles, they are also equal. So we are saying they are equal. So remember the concept of your vertically opposite angles. So let's see on our diagram. There we have got vertically opposite angles. We are creating X, angle A to angle D, angle B to angle C. So these angles are supposed to be related A to D. So we are saying angle A is equal. Remember, they are equal. Angle B and angle D. So B is, and angle C, B is equal to angle C. Also, on this other hand, we have vertically opposite angles there, considering angle F and G, angle E and H. They are also equal. So we are going to consider these angles. We said F and G. So angle F is equal to G. E is equal to H. Angle E is equal to H. These are vertically opposite angles. So with this, or with these angles that we just listed here, questions will be asked. So you must answer the question using the concept. Is it about vertically opposite angles? Is it about the co-interior? Is it about the corresponding or the alternate angles? And also, you must consider angles on a straight line. That part we already know, guys. Working with a straight line, A and B is on a straight line, so add up to 180. C and D, that part of a straight line is not going to change. B and D, F and H, G and H, E and F, angles on a straight line add up to 180. That part is not going to change. So we are going to see that part in our revisions, like if it is to be used. All right, so let us consider our questions here. So we are going to answer these questions as we are given an example here. Find out the sizes of the unknown angles. Give reasons for your answers. The first one has been done as an example. Like, this is how they want you to attempt whatever part that you're going to have. You must have a reason. So we can have these reasons in short, like considering alternate angles, corresponding vertically opposite co-interior angles. We can write these in short, like what we can see on this presentation. All right, so we have got, in this case, find the sizes of X, Y, and Z, and we're given two lines which are parallel, line AB parallel to line CD. Okay, so we can find angle X. Remember, from the parallel lines, we said when we create a Z like this, we are creating a Z. So this angle and this angle are alternate angles. They are equal. So if this is 74, X is also going to be equal to 74. They are alternate angles given what? With given 74 degrees. From which concept? The parallel lines AB parallel. So this, remember, is short for parallel, is parallel to. AB is parallel to CD. So we've got angle X. With angle X, we can also find this angle Y here, why we are creating that F, even though it is just slanted like that, is F. So remember your corresponding angles. We said one angle outside, another one inside. They are corresponding to each other. So if this is 74, this is going to be 74 degrees, corresponding angles. So that is, they are corresponding angles in this case. That is what you can have. Or in this case, besides the corresponding angles part, we can see that these two lines, they meet, they actually cross each other like this. So remember, the part of vertically opposite angles, the angle here and the angle here, they are equal, vertically opposite angles. So this angle can also be 74 degrees because it is a vertical opposite angle with the 74 degrees that we are given. So many ways that you can use to answer that. All right. Then to find Z, we can consider angles on a straight line. Z and this 74 degrees, they are on a straight line. Z and this Y are on a straight line. Or you can consider the co-interior angles. Remember, when you form a C like this, these are co-interior Z and X. We said when you form a C like that, they are referred to as what? Co-interior angles. And they add up to 180. So it's up to which part we're going to consider. Is it angles on a straight line? Is it the co-interior angles? If you're using the co-interior angles, it means if you add Z and this 74 degrees, you must obtain 180 degrees because angles, these co-interior, they are supplementary. So Z was going to be 180 degrees minus 74 degrees. You take it to the other side. Remember, solving of your equation, that was going to give you 106 degrees, which is the same answer that you could have used about angles on a straight line with angle Y, or angles on a straight line with the angle 74 that is on the other hand adjacent. Remember that concept of angles on a straight line, they add up to 180. Still, you're going to have the same answer. So the reason is supposed to be from what you are using. Which part are you using? That is the reason. So in this case, we want to work out the sizes of angle P, Q, and R from these lines which are parallel. Line KL is parallel to line MN. These two lines, they are parallel, having GH or HG as our transversal line. All right, let's start with the Q. It's direct there. Even the P, you can have it that way, P, Q, or whatever that you want. For P, maintaining the order that you want there, you can use this concept, all right? There we are forming F. Remember that F there concept. One is inside, another one is outside. So these are corresponding angles. So meaning to say P and 133, they are equal. Remember the concept of corresponding angles where you form F. They are equal. Remember that. So P is equal to 133 degrees. So in this case, P was equal to 133 degrees. There we are talking of the corresponding. So you can even write in short like what we had there. So these are corresponding angles, corresponding angle with 133. So it's a corresponding angle with 133 degrees, which is the angle that we are given there. From what? The parallel lines, since KL is parallel to MN, all right? Since KL is parallel to MN, these two lines, they are parallel to each other. So meaning to say those angles will be corresponding. So this is how you answer the questions. Also, fill in the information from what you've just answered. Fill in that information. You now know that this P is 133 degrees. Also, write it there. All right, let's consider P and Q. We are forming a Z, even though it is just stretched like that, but it is also the Z alternate angles. So this angle and this angle, they are alternate. Or we can consider Q and this 133 vertically opposite angles. So that one, it's up to you. which part were you going to use? So Q is equal to 133 degrees. That is vertically opposite angles. All right. So we have the part of vertically opposite angles. Vertically opposite angles. All right. Or we can consider this to be equal to P. All right. We can consider our Q to be equal to P. And in that case, we are referring to the alternate angles, the ones which form a Z. So it's alternate angle to angle P, alternate to angle P. From the parallel lines concept, you conclude with that statement that you used there, KL is parallel to this. So we have got our angle Q. We can use that, but what we do know is that this is 133 degrees. All right. From there, we can find angle R. So angle R, we can use again the corresponding angles because we are forming an F like this. So this angle Q and angle R, they are equal corresponding angles. You can use that, or we can use the vertically opposite angles here between R and P. So R at the end is going to be also equal to 133 degrees. We are referring to the vertically opposite angles, or we can refer to the corresponding angles to what? To Q. So whatever part that you're going to use there, you can talk of the vertically opposite angles to that 133, or you can refer to the corresponding angle to what? To angle P, angle Q and R. All right, that is to angle Q. So guys, the reasons there is how you answer the question. As long you follow the concept, the theorems there that you were working with on your parallel lines, you are going to obtain exactly the same answers in your presentation with the different way of view. But as long you are following these, you are going to have the same answers. All right. Again, we are given there. Find the sizes of A, B, C, and D. All right, so angle A, guys, is direct there. We can use the vertically opposite angles, these two. That is going to be 140 degrees. So A is equal to 140 degrees, vertically opposite angles. All right. Angle A and B, they form that F, even though it is looking this way. So remember the corresponding angles. So A and B, they are equal corresponding angles. So A is equal to B, so it is equal to 140 degrees. So meaning to say angle B, 140 vertically opposite angles, or you can use alternate angles concept. This is 140. This is also going to be 140, where we form a Z, alternate angles. So I do not know which reason we're going to use. To find angle C, we can use angles on a straight line. We can use the co-interior angles, all right? They here where we form a C. That's our co-interior angles. So angle C is going to be 180 degrees minus 140. Remember, they add up to 180 degrees. So meaning to say it is going to give us 40 degrees. Using angles on a straight line or using the co-interior angles, it's up to you. Then angle D, vertically opposite angles to 140 degrees. So it's also 140, or you can use angles on a straight line, or you can use the corresponding angles concept. It is corresponding to this 140. So it is also 140. So guys, you see, so many reasons. You just have to use the one that you understand or that you are using from the way of your understanding. Number 4, find the sizes of all the angles in this fig. All, meaning to say everything that we are seeing here. So let's see, we have got 130 degrees here. So meaning to say that angle on this other side is going to be 130 degrees. All right. So remember, this is K. So this angle at K is also going to be 130 vertically opposite angles. So that's C, K to J, this angle here from C to K to J. All right. So we've got angle C, K, J, which is 130 degrees. All right. Also, angles on a straight line, they add up to 180. So meaning to say these angles are on a straight line. We can use that concept. So 180 minus 130 degrees is going to be 50. That will be 50 degrees. So this angle is 50 degrees, which is angle CKF, C to K to F. So there we have got angle CKF, which is 50 degrees, all right, from angles on a straight line. Also, this one, this side is going to be 50 degrees. That is from D to K to J. That is angle DK to J like this. It is going to be also 50 degrees, vertically opposite angles. Remember that part of your vertically opposite angles. So this is what you're going to do. You answer that part, everything. You can consider alternate angles like this. So if this is 50 degrees, this is also going to be 50 degrees. Remember, alternate angles are equal. So angle A to J to K like this, angle AJK is going to be 50 degrees vertically up. The alternate angles in that case. Then it is vertically opposite to this one, which is EJB, from E to J to B, which is also 50 degrees. These are vertically opposite angles. Angles on a straight line. So if this is 50 from 180, this will be 30 degrees. This will be 130, or you can use the co-interior angles. This angle and this angle, they must add up to 180 degrees. So still you're going to have the same thing. That's 180 degrees, 130 degrees on these two angles. They are also vertically opposite angles, remember? So meaning to say, from this point K to J to B, or B, J, K, B to J to K like this, that is 130 degrees. Also from A to J to E, 130 degrees. It is also 130 degrees. So you can fill up everything using whatever concept, but these are the answers that you must have. I don't know which way are you going to apply or are you going to use, but that's the condition that you must have. Understand, work with your reasons, whatever that you are given, you must provide the reasons. So in that case, as I was explaining, I think I was giving you guys the reasons. So make sure you do work with those reasons when answering these typical questions.